This is Dr. Nandi. For those of you who do not know me, I frequently lecture on statistics. I solve statistics problem online just to help you. I solve all kinds of math problem. So please visit my channel and subscribe to it by hitting the red subscribe button. I have solved all kinds of math problem just for you. So if you like my videos, please give me a thumbs up. That really motivates me. And please also subscribe to my channel by hitting the red subscribe button. So today we are going to work on a problem on statistics probability distribution problem. Says a 50-ounce weight was repeatedly weighed on a scale 0.5 ounce and the standard deviation was zero point 0.1 ounce. The probability distribution of the weights is not bell-shaped. This is important. Not bell-shaped, and bell-shaped I'll show you quickly what it is. At least what percentage of the weights will fall between 49.3 and 49.7 ounce. So the mean of the weights is given as mean is mu. I'll use a better pen. Mean is mu is given as 49.5 ounce, and sigma, the standard deviation, sigma small s, Greek small s is population standard deviation, is 0.1. Now we have been given two other weights, two other boundaries. The lower boundary is 49.3, the upper boundary is 49.7. So the first thing we will do is take the smaller weight or lower boundary and find out what is the difference, which in statistics is called deviation, of 49.3, or difference of 49.3 from mu 49.5 is x is the number 49.3 minus mu equal to 49.3 is the number, the lower boundary, minus the mean 49.5, and that is equal to 0.2. Okay, so what does it mean? It means the number 49.3 or the weight 49.3 is located away from the mean 49.5 by 0.2 ounce. This is minus 0.2 because 49.3 is less than 49.5. Similarly, deviation of 49.5 from mu equal to 49.5 is again x minus mu. In this case it is 49.5, the upper boundary I'm mistaken is 49.7. So deviation of 49.7 from 49.5 is x is 14, that is the upper boundary. So I first dealt with the lower boundary, now I will deal with the upper boundary. 49.7 minus 49.5. This is also the, but however 49.7 being greater than 49.5, this is 0.2. So they told us that this distribution, the distribution of weights, is not bell-shaped. Bell-shaped is just like a Liberty Bell, inverted. Here it is not bell-shaped. That means it may have an extended tail on the left or an extended tail on the right. Suppose we think of a positively skewed distribution. Positively skewed distribution is extended tail on the right. Extended tail on the right. Tail on the right. or on the positive side. So this distribution will look like this. So you have the weights on the horizontal axis and you have the probability on the vertical axis, and we are drawing the probability density curve, and it will look like this, extended tail. So this is not a bell-shaped distribution. A bell-shaped would have been a complete bell, an inverted U, but this is not true. Not a bell-shaped distribution. Specifically, this is positively skewed, means extended tail on the right. What does it mean? Majority of the numbers where the frequency, relative frequency of probability is the highest, somewhere over here. Majority of the numbers are here, but then there are some large numbers in the distribution too, which pulls the mean towards it. So it's an extended tail on the right. Okay, this is positively skewed. Skewed means heavy on the right, positively or right skewed. Okay, and in this case, particular case, the mean is said to be 49.35, standard deviation is sigma is 0.1. So mean is 49.5 where the relative frequency is highest. That's your mean on the horizontal axis. And sigma is 0.1. And we have been given two boundaries. Let me use another pen and show you the two boundaries. One is over here, another is equal distance over here. So this one, this number is 49.3, being below 49.5, below on the left, and this number is on the right of the mean, higher than the mean is 49.7. So here is one, here is one. And both of them are 0.2. This is minus 0.2 because it's on the left of the mean, and this is positive 0.2 on the right of the mean. So let's find the normal score Z. This is the normal score for 49.7, and that would be given as Z is equal to x minus mu over sigma. So it is 49.7 minus the mu is 49.5 divided by the mu sigma, standard deviation is 0.1, or 0.2 over 0.1, which is 2. Okay, so this particular point 49.7 is has a Z score, standard normal score. Z is 2. That means 49.7 is located 2 standard deviation above the mean. 2, the number 2 is coming from the Z score. 2 standard deviation, STD standard deviation above the mean. Okay, and the other one, okay, let's look at the Z score for normal score for 49.5. 49 normal score for 49, the other boundary for 49.3. Okay, and that is also Z is equal to, let's call this Z1, let's call this Z2 is x minus mu by sigma. Now here x is the number below the mean, 49.3 minus 49.5 divided by 0.1, or minus 0.2 divided by 0.1 is minus 2. What does it mean? It means Z2 score of Z2 is -2. That means 49.3 is located, because of the negative sign, is located 2 standard deviation below the mean. Deviation below the mean. So both of them are located twice the standard deviation. One is above the mean on the right, one is 2 standard deviation below the mean on the left. Okay, the distance from the mean is same, 2 times standard deviation. Because this is not a bell-shaped distribution, is not bell-shaped, then we are going to apply Chebyshev's rule. Apply Chebyshev's rule. Chebyshev's rule. Why? Because probability distribution is not, because distribution of weight is not bell-shaped. Of weights is not bell-shaped. Is not bell-shaped. Okay? That's why we are going to apply Chebyshev's rule. So what does Chebyshev's rule state? That at least, let me see if I can write with this. At least 95% of the data, in this case measurements of the weights, will fall within 2 standard deviation. Sorry, not 95%, at least 75%. For Chebyshev it is 75%. And we apply Chebyshev when the probability distribution is not bell-shaped. Is not bell-shaped. At least 75% of the weights will fall within 2 standard deviation from the mean. 2 standard deviation from the mean. That is between 49.3 and 49.7. So that is your answer to the question, 49.7. So let me erase that and write it correctly, 49.3 and 49.7. So what did I do? I found out it is given the mean is 49.5, standard deviation is 0.1. I have been given a lower boundary of 49.3 and an upper boundary of 49.7. I found out what is the deviation of the lower boundary, 49.3, from the mean. Because it's below the mean, that deviation is minus 0.2. And because 49.7 is on the right of the mean, its deviation from the mean or difference from the mean. Deviation means difference. In statistics we call it deviation instead of just difference. So deviation of 49.7 from the mean is also 0.2. Now they told us this distribution is not bell-shaped. Bell-shaped is like an inverted U. Here we have shown a distribution which is positively skewed. It is not bell-shaped. Why? Because we have an extended tail on the right. What does it mean? There are some small numbers which have the highest frequency. That means the center of the data, the mean is around this place. But on the other hand, there are some very large numbers with small relative frequency, extended tail on the right. This is an example of a positive skewed distribution. So the mean is at the center where the relative frequency or the height is the highest. It is 49.5. We have a lower number 49.3 and a higher number 49.7. Both of these numbers are located 0.2 away from the mean as we have determined their deviation. The one below the mean is minus 0.2. Then we found out the normal score of each of these numbers. One we called Z1 on the right, the other we called Z2. What is the definition of standard normal score? It is the deviation from the mean divided by standard deviation. Since our standard deviation is 0.1, and in the case of the larger number, the deviation is 0.2. 0.2 divided by 0.1, the standard deviation is 2. What does it mean? The point 49.7 is located 2 standard deviation above the mean. So the z-score for 49.7 is positive 2 because it's above the mean. The z-score for 49.3, which is below the mean, is similarly minus 2. Why minus? Because it is below the mean, the difference is minus 0.2. Divide that by standard deviation, 0.1 is minus 2. Okay. Now we have been asked what can be said, what percentage of the weights will fall between 49.3 and 40. Since both of them are located 2 standard deviation below the mean for 49.3 and for 49.7 it's 2 standard deviation above the mean, same distance. The Chebyshev's theorem, which applies for any kind of distribution, says at least, that is why the question was at least means 75% is minimum. At least 75% of the weights in this case will fall within 2 standard deviation of the mean, that is between 49.3 and 49.7. So the way to approach these problems is to find the deviation from the mean, then divide the deviation by the standard deviation to get the normal score. In this case, both the points, one is 2 standard deviation below the mean, one is 2 standard deviation above the mean. And because the distribution is not bell-shaped, we'll apply Chebyshev rule in this case, which says at least 75%, minimum 75% of the data will fall within 2 standard deviation of the mean, which in this case is 49.3 and 49.7 ounce. So I will stop here today. If you have any question, please do not hesitate to shoot me a question and I will respond to each and every one of your reply. I assure you that. And if you like my video, please give me a thumbs up. If you like my video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button, which is at the bottom right corner, and please also at that time hit the notify bell button, which will notify you every time I upload a new video, which I do quite often. And please come back tomorrow to check the new video that I will be uploading. And I thank you for taking the time to visit my channel and listen to my presentation. Thanks a lot. Have a great day and I will see you tomorrow. Take care. Have a nice day.